Hello and welcome back. So, we're going to kick off with our next talk. But first, housekeeping. As always, please go onto Twitter and use our hashtag WTF is SRE, to be caught up with all of the tweeting that goes on over there. And also, we do have a code of conduct. Don't forget about that. And check out our amazing sponsors who make all of this possible. So, for our next talk, I would like to welcome Margaret O'Toole. She works at AWS and she works in reliability, and she's going to talk about reliability. So, Can we have Margaret here?
Hi, thanks for having me.
Awesome.
Hello.
Thank you for being here. So, as a reminder for everybody, if you have any questions during the talk or after the talk, there is a little Q&A section in the chat next to this window. So it should be over here. Over here. Next to my face. There is a chat window that you can put your questions in, and we will ask Margaret after the talk. So we do have a couple of minutes to chat to her once the talk is over. And yeah, so your talk is adopting green SLAs and SLOs, introducing sustainable reliability. Amazing. Yeah. That's the title. So feel free to go ahead, Margaret, and everyone enjoy the talk.
Great. Like I said, thanks so much for having me today. We're going to talk about sustainable SLAs. A bit about myself. My name is obviously Margaret. I obviously work for AWS. And my job is focused on sustainability. So we talk about sustainability in two lenses in my line of work. So the first is really, as technologists, how do we use technology in the most sustainable way possible? What does that mean for good design and good practices in general? And that's most what we'll be talking about today. I'd say we also have the other side of the coin, and we'll touch a little bit on this at the end, but it's really more around how do we use technology to drive the right kinds of solutions within sustainability. A lot of challenges around sustainability are data challenges. They're challenges that really make us rethink how we view the natural world and how we interact with it. And there's a lot of elements from SRE that are really relatable to solving these challenges. So we'll touch a little bit on both these topics. And just hopefully you leave this session with a sense of how to evaluate trade-offs a little bit more concretely in your own world, and just get you thinking a little bit more about what sustainable design might mean for you and your teams. So I'd like to first set the scene a little bit and just talk kind of like, why are we here? So I'd like to focus on this idea of a sustainability transformation, which is really, we can't continue to operate in the way that we have been. We need to fundamentally change how we are operating our businesses, how we're existing in the world, how we work with each other even. And this isn't really just something that is one direction, right? This isn't just, adopting electric vehicles everywhere. We really need to fundamentally think about how we exist. We have to really transform all parts of our life. And I'd also like to clarify a little bit about what I mean when I talk about sustainability, because this is a word that gets tossed around quite a bit and maybe has lost some of its meaning over time. So sustainability is a broad area. It's a broad topic that covers many different elements, right? So in an academic sense, sustainability has three pillars. It's economic, it's environmental, and it's social. And these three pillars kind of play off of each other, and they really help design or define how different parts of our society should interact with each other. So you're probably familiar with talking about decarbonization. This is obviously a huge part of sustainability, but it's not the only piece. There's also water use, biodiversity protection, social responsibility, circular economy. There are many, many, many components to sustainability that we need to think about, especially as individuals who have the skills that are really relevant to solving challenges within sustainability. The digital transformation is something that I think is a pretty good parallel for sustainable transformation. I mean, we think about the digital transformation as really having transformed how we operate, right? I mean, Netflix couldn't exist if we hadn't gone through the digital transformation. This is a net new business model. It is, I would say, pretty fundamental to how we existed, especially during lockdown. And it's something that we well understand, right? We understand what a digital transformation is. We understand what value this brings to us as people and also to businesses. And now we need to take all of these learnings from the digital transformation and apply them to the sustainability transformation. And the big challenge is digital transformation is something that can take months or maybe years, depending on the size of the project, the business model itself. But sustainability work takes a long time. So the question is, how can we deliver a result faster? How can we accelerate the process towards a sustainable transformation? And I'd like to spend some time today talking a little bit about how we can optimize workloads. So what does this mean? If we're going to design for sustainability, with this in mind and really make this kind of a key criteria for us as engineers, as builders, what does that mean for things like SLAs? What does that mean for how we design and build systems, how we use systems? But really, how do we optimize workloads with the intention of reducing its environmental impact? And we talk about this concept, this optimization concept, as sustainability in the cloud. And essentially, what it is it's a focused effort, and we're looking to reduce energy consumption and increase efficiency. When you think about these kinds of optimizations around IT, you think about, okay, well, and if I want to use less energy, shouldn't I just use less? Just do fewer things and do it with fewer resources. And to some extent, that's true. I mean, fundamentally, but it doesn't really align up with reality. I mean, we really need to start to think about this as a trade-off, as a part of the larger ecosystem of how we work as technologists. And maybe to think about it a slightly different way, we're very familiar with metrics. I mean, you guys all know. We work with metrics as a key part of our day-to-day operations. We understand how much storage we use and how much compute we have and how well it's being utilized and how much data transfer that we have and all of these different components of things that we can measure, things that exist in our environments that we understand and we use every day. And we can think about how these work together with non-functional requirements, right? We can think about how much our storage is related to data transfer and potentially cost. And we can think about how much our utilization rates influence availability. We can think about the type of storage that we have and its response time. And these types of metrics and the types of non-functional requirements we have are existing in a little bit of tension. We have to look at multiple data points in order to draw clean conclusions. We also have to understand how these play off of each other to make trade-offs, right? So maybe we decide that because sustainability is a non-functional requirement, this is a non-functional requirement that's especially important to us. So we're going to make it a key part of how we design. So we say, okay, if sustainability is a key non-functional requirement and we're looking at another non-functional requirement, maybe quality of result, how do these play off of each other? And maybe one way we could do this is, when you have a search result that comes up and it says, you have 134 results. We obviously had to count the number of results in order to display this in the UI. A potential optimization here could be just to say you have more than 100. We didn't necessarily have to count this. You could just say there are lots of results. There are this many pages. There are other ways to look at these kinds of smaller tweaks that we can make in our code in order to reduce the overall utilization, again, with the intention of increasing efficiency and decreasing energy requirements. And if we take a look at response time in a little bit more detail, I'd encourage you guys to take a look at the different storage options that are available to you. So when the underlying technology behind storage is designed, there are certain trade-offs that you have to make here, right? So the speed at which you can access the data typically means that the actual hardware behind it is more energy intensive, right? So if you need it right now and it needs to always be available right now, the underlying storage devices are more energy intensive than if you were to consider slower, less responsive storage options, the energy required to power that workload would be less. So in this particular case, maybe we can think about how critical is access, right? I mean, if we look at S3, for example, we have plenty of options, right? I mean, if our SLA to customers, when we say how much storage or how fast do you need a certain asset, maybe millisecond access is fine. But then does it have to be millisecond access from S3? Or can it be something that's more about infrequent access where we would have a lower energy cost at rest, but potentially a lower response time when we go to retrieve that asset later on in the future? This isn't to say that you should always be looking to reduce your response time, but more just to plant the seed that there are trade-offs here, right? I mean, when we talk about tracking emissions, which you can do for AWS workloads, we talk about how you can reduce them. Obviously, as soon as you have this number, the next step is, how do I make this number smaller? And moving through different storage classes is one key way to reduce emissions. And so where it's possible to adjust response times, moving through different storage classes can also net a benefit in terms of the emissions attributable to that workload. And when we look more closely at other elements of this, right? So, again, looking at response time, we can consider compression, right? So when we compress a file, it's obviously going to be slower to access it because we have to decompress the file and then have access to it. But when we also think about what this means in terms of data at rest, there are some massive implications to this. So just to give an example from a team internally, there were a large amount of logs stored for a variety of different teams who were working internally at AWS. We actually have a program where we kind of announce these operational wins, and this is one of these wins where we can celebrate the different optimizations that a team made that improved the operational excellence of that team. So in this particular case, we had some teams who were looking to reduce the amount of data that they had at rest. And so they decided to switch their compression algorithms from gzip or LZ4 to Z standard. And just this change, which ultimately, changing compression algorithms can change the time it takes to access a file, this resulted in saving about an exabyte of data. So again, when we think about the impact of these smaller decisions, and yes, potentially you're going to increase response time, you're going to have a much larger benefit saved in terms of the storage at rest cost. So again, not that we always have to reduce our response time, but just that there are many ways to do this where they have other net benefits across the other parts of the workload, right? So here's a clear case where you would have obviously energy cost savings as well as financial cost savings, with potentially, obviously, depending on the algorithm and how exactly you've structured it, there could be an increase in response time. And we've decided to kind of consolidate these different best practices around how to design into something called the well-architected pillar for sustainability. And for those of you who are, well-versed in AWS, you're familiar with the well-architected framework. But for those of you who might not be, the well-architected framework is basically like a distilled set of best practices from lessons that we've learned and lessons that our customers have showed us that they've learned from how to build best in cloud. So if we're going to build a workload that's really intended to deliver on a certain purpose, these are the best practices that we should follow in order to make sure we can actually action and actually deliver on that purpose. So recently we launched the sustainability pillar as part of the well-architected framework to really call out key, clearly defined best practices on sustainability that really highlight how to build better and what we should be thinking about when we talk about actual sustainable design. What kinds of opportunities are there for reduction? And at its core, what we're talking about when we're looking at these different challenges, and maybe you've picked up on this from the previous two examples, but what we're really looking to understand when we work with customers on this is this concept of resources per unit of work. So obviously, it takes some number of resources in order to power your workload. We generally know what this is, right? I mean, we know how much storage we have. We know how much compute we have. We generally know how much network transfer we have. But we don't contextualize this number, or we're maybe reluctant to contextualize this number. And the idea that we're really trying to pull out from the well-architected pillar is this exact concept. If we're trying to drive efficiency in our workloads, we should be driving towards reducing this relationship, right? How many resources does it take to complete a unit of work? That unit of work could be anything, right? So if you're, I don't know, a bank, your unit of work could be mortgage applications. If you are, I don't know, a retail company, maybe it's customers you've served. It could also be something more generic like transactions, and that can mean whatever it means for that particular application. But really trying to understand how many resources are required in order to complete a task. Once you've done this, this can help you identify areas of waste. So where are there opportunities for potential optimization? Maybe you find that the compute resources it takes for a unit of work is much higher than you would have thought. Maybe you find that it's just where you expected and you can focus on storage or some other element of the workload. But really getting into the nitty-gritty details of what have you actually provisioned and how much work are you actually getting done with it? And then once you've had this understanding, you can apply this to other elements of the workload and start to really drive through core efficiencies. I'm not going to go through the whole well-architected pillar. It's all publicly available, and I strongly encourage you to read it. We also have some labs out, and it's also integrated into the well-architected tool. But just to give a few highlights of the kinds of advice that's in the well-architected pillar for sustainability, the first is to start to think really critically about the hardware you're using. There's certain hardware that we've designed with the explicit intention of it being more energy efficient, Graviton instances being one example. We also encourage the use of serverless. Obviously, this is a very clear way to reduce the resources consumed because it's, you're only using it when you're using it for a brief period of time, and then it's gone. It's reusable by someone else, or it's gone back into the pool. So serverless is another option for you to reduce the overall resources, when you're actually using it for the appropriate workloads, event-driven workloads, and this kind of thing. I'd also call out two different tools within AWS. So we have the instance scheduler, which will obviously shut off and terminate instances when they're not in use. And again, this goes back to the idea that if you're going to provision something, you should be using it. Otherwise, it's counting toward this resources per unit of work relationship. So the instance scheduler is, I would say, relatively low-hanging fruit to help tailor these optimizations. There's also the cost explorer. This will help you better right-size different parts of your workload, which again can really help drive down this relationship of resources per unit of work. Often you'll hear the saying that you can't improve what you can't measure, and this is definitely the case. So we've recently launched the Customer Carbon Footprint tool, which will allow you to see the emissions attributable to your AWS usage in a specific account. It will also give you a forecasted path forward, what we expect that your emissions will be based on your usage and also our renewable energy predictions. It will also give you, obviously your historical data so you can measure progress over time. And I mentioned this obviously for a lot of reasons. I think as a sustainability expert, this is a very exciting tool to see launched, but also because as we have improved metrics around carbon and a better understanding of the emissions attributable to a workload, there's still a really important component of how do we actually understand that number. So we still have to continue to measure these non-functional requirements. We still have to measure our resources per unit of work to help to contextualize these kinds of numbers, because the number on its own doesn't necessarily drive the optimizations that would further reduce it. Whereas understanding how many resources it takes for a unit of work and looking at this as your carbon footprint changes over time, these data points together will drive the right kinds of design decisions. I'd like to take time for another kind of more explicit example of how we can optimize for sustainability that's really, really related to SLAs in general. So let's consider the scenario where we have some capacity. We have decided that for this particular workload, we require immediate failover. And because we require immediate failover, we have to provision our workload into two regions or two availability zones, and we have to have spare capacity for a hot failover, right? So we have to immediately be able to carry that workload over into the other availability zone in the event of a failure. So this means in any scenario, we're never going to go above utilization of 50% because we have to have twice the amount provisioned than we need in order to immediately fail over to that area. And this is great. If we have to have a failover, we can immediately fail over and everything's great. We've met our SLA for sure. And we're able to cover the loss, in the event of a failure in the availability zone A. And for that type of scenario, that might be fine. But let's take a look at another scenario. Let's say we still have the same workload requirement for immediate failover, and we still have the same workload, but we've decided to distribute that workload across 3 availability zones. But now we're able to achieve a much higher utilization rate. So if you're familiar with how hardware is working underneath the hood, a processor that's operating at, let's say, 30% is consuming energy much less efficiently than that same processor that's operating at maybe closer to 80%. So we really want to drive up utilization, not just because of this principle that if we're going to provision it, we should use it, but also because typically as we have higher utilization rates, we also have higher energy efficiency rates. So in this particular scenario, we're meeting our SLA. We still have the same, immediate failover if we need it, but we have a higher average utilization rate. So when we're not failing over, we're not necessarily wasting as much capacity, but we're still able to deliver on the actual need that we had. And if we consider this same situation just under a slightly different lens, we can take a look at what this means for changing the SLA in general, right? So let's consider the situation where we've decided to adjust our SLA. We can now relax it a little bit, and we can accept a few minutes of outage, in the event of a failover. So we decided we're going to run in one availability zone. We're going to achieve super high utilization, and then we'll use cold capacity in the event of a failover. So we drive over the workload into availability zone B because in the event of a failover we have to go somewhere. But there's a trade-off here, right? Obviously, we have this high utilization rate, and that's positive, but we have had to relax the SLA in order to do this. So there's a trade-off between these two options. But in general, the architecture recommendation is to take a look at your SLAs. Make sure that you're delivering on what you've promised you're going to deliver on and no more. Make sure that you have evaluated the SLAs appropriately to the business need, right? A lot of the customers that I work with are way over delivering on SLAs. And that's obviously, it sounds like a great, option, but we should be thinking critically about the resources that are required in order to deliver on that SLA and how relatively important that is for any given particular workload and the world in which it exists, the context in which it exists. And I'd like to take a moment to give you just one last example talking about workload scheduling. What we find is that people tend to do the same things at the same time. We like round numbers, we like top of the hour scheduling, we like midnight scheduling, and these types of peaks can create resource contention. And again, when we talk about provisioned capacity versus used capacity, our total provisioned capacity is the total area under the curve. And when we're doing all of these same activities at the same time, we end up with peaks in our provisioned capacity versus potentially our used capacity. But if we're able to distribute out our schedules, instead of running our schedules at regular intervals, we reduce the area under the curve and we can reduce the provisioned capacity that's required in order to do this. So the reason I call this out is because as we talk about metrics that are helping you make informed decisions about sustainable design, you really need to look at the total provisioned capacity, not average. It helps you to find these kinds of outlying pieces of data, these strange behaviors that maybe otherwise would be hidden in averaged information. Obviously, we've talked mostly in this session about different design opportunities and optimizations that you can make or trade-offs that you can make to better understand how your SLA relates to your workload's energy consumption or environmental footprint. But there are some core SRE concepts that I think have a huge role to play in the broader sustainability community. And I'd like to just make one quick example. So we have a program called ASDI. It's the Amazon Sustainability Data Initiative. And essentially, it's these free data sets. They're used to help drive research and other understandings within climate. And obviously, anyone can use them. They're free data sets. Actually, I would strongly recommend taking a look. They're super cool. But we have one customer who recently used it in order to drive new insights in an industry where real-time information is very difficult to find. So Nautic AI is a Finnish company, but they help companies who are doing freight shipping have real-time information about what route changes they should make based on weather conditions. And historically, this has been a very difficult industry to derive real-time insights from. So having this kind of opportunity is allowing for groups to reduce fuel usage, right? Because they're going to take the most efficient route for the weather conditions they have, reduces idling and these kinds of other times where you would potentially be wasting fuel, which in maritime shipping can be a big problem. So the point of this example today is really just to say, although the design principles of a sustainable design tend to focus on relaxing an SLA or at least evaluating how best to deliver on that in order to reduce resources, that's not to say that real-time insights don't have a very important role to play in sustainability. It's really just to think about how critical is the decision you need to make and how fast do you actually need a response to that. And just to think critically about the types of trade-offs that are available to you and to the workload. I would leave you with two items. The first is I strongly encourage you to take a look at the well-architected pillar. There's some best practices there for all kinds of different workloads. So you can look at data patterns as well as user patterns and really everything in between. There's a really well-defined section on the improvement process and how to define opportunities. So I strongly recommend taking a look at this and then find ways to understand trade-offs within your own workloads so that you can apply these kinds of optimizations. But I would also encourage you to take a step back and to think a bit bigger about how your skills in automating and scaling and designing reliable software can support the broader sustainability strategy of your organization. There's a key role for technologists to play in the sustainability transformation, and we just need to step up and start asking how we can help. So that's all that I have. Thank you guys so much. And I guess if there's any questions, I'd be happy to take them.
Hey, Margaret, thank you so much for the talk. It was very interesting. There were some really cool things in there, like the tiny little things that you can change in order to make a massive impact on a large scale. So that was really cool. We have a big question. So it's one question by Max Conover. Can you talk about AWS's plan to get to 100% renewable energy by 2025? What does AWS define as renewable? The big question, if you have some thoughts on that.
Sure, yeah. So there's actually a couple layers to this. So AWS is obviously a subsidiary of Amazon, and so we have the overall climate pledge, which is a commitment to be net zero emissions across all Amazon businesses by 2040. As a part of this commitment for the climate pledge, there's this kind of, I would say, a transitory goal of using 100% renewable energy to power all operations in all Amazon businesses by 2025. It was actually an initial goal of 2030, and we've just been moving faster than expected. So now we're on path for 2025. And then in terms of what that means for AWS, obviously this will decrease the Scope 2 emissions. So Scope 2 is the emissions generated from utilities consumption. We have been procuring a lot of renewable energy recently, and I think one really important part of our strategy has been not just the purchase of credits, but our massive investments in actual net new renewable energy projects. So we actually announced earlier this week that we've reached 310 projects around the world. So these are net new projects, net new wind farms or solar panel projects that are then obviously going into the grid systems in the communities where we operate. So our strategy has always been to pursue the most credible renewable energy sources, and this has often meant creating new projects ourselves, or obviously with people who create projects, or renewable energy companies and the like.
Yeah, thank you very much, and thank you, Max, for asking the question. Iliri, you also have questions.
Yes, and there's one other question here that I see in the chat. It says, are there any benefits of Graviton 2 based instances over Graviton 3?
It's a good question. I mean, obviously, as we have more recent hardware, we get increasingly efficient. So when we compare Graviton 3 instances against a comparable instance, so say like a C series, it's about 60% more energy efficient. I haven't done any baselining myself versus Graviton 2 or 3, so I would actually be interested to see if maybe a customer would do that and let us know. Just kidding. Now, I think between Graviton 2 and 3, I would expect generally that Graviton 3 would be more efficient just by virtue of it having been newer and it's the next generation of. But I think it also depends on what you're doing, right? So obviously there's a little bit of fine tuning that's required for any specific workload and exactly what you're going to be doing on that hardware.
Cool, awesome. And I've got another question. So this was a really interesting talk, actually. Talking about sustainability, it's interesting how much impact your choice of your configuration choices can affect the environment. And for me, I'd never looked at it that way. I'd read about the cloud and how there's been a lot of impact on the environment and all of these things. So it's really good to see that I can make the choices that impacts the environment. So what I want to ask is, for beginners, there's this choice with beginners tend to, misconfigure things. All right. So how do they, where does that balance come into play, between just provisioning cloud infrastructure and, looking at sustainability? What would you advise?
I think this is really one of the main reasons that pushed for carbon related metrics. Like carbon related metrics are super important, but we need to also speak in the language of the work we're doing. And that's where these resources per unit of work metrics become so applicable. And if I were just starting out, I would first look at my utilization. Just blanket, like, what am I actually getting done with what I've provisioned? How much of it's right-sized? What is the average utilization rate? What is the actual utilization rate? And just use this to start to get a sense for, again, how much work am I actually getting done? Like, what's the productivity of these resources? And start thinking about really, I mean, not to forget about carbon related metrics, but really think about it in terms of the actual technology, just the metrics that are available in CloudWatch or these other types of monitoring tools, and just start to get a feel for what these high utilization rates mean. And then of course you can, as your sense of understanding increases, you can continue to find ways to fine tune. Maybe you decide that you're going to explore using Rust, for example, because now you understand how much work you can get done now that you've provisioned, your workload and your software is written in Java. But now you're going to try something totally different for this, specific microservice that you're going to do. And then you can compare that against, the known kind of resource per unit of work metrics you've already seen and keep fine-tuning from there.
Awesome. Thank you for that. It was a really lovely talk. Thank you so much.
Yeah, thanks again for having me. It was great to be here.
Thank you so much.
All right. Okay, just a quick reminder, for everyone who is watching, you can tweet at us. You can, use the hashtag WTF is SRE, and ensure that you're, putting things on Twitter. We're going to definitely retweet and like them. And please ensure that you follow the code of conduct on the website. You would see, you scroll to the bottom, you'll find the code of conduct. So please be very good. And we'll be going for a quick break and we'll be back in 15. Thank you.
Okay, see you later.